Dear students, welcome to the video multiplication of a matrix by another matrix. In this video, we are going to learn how to multiply two matrices. Now, in general, if the number of columns of the first matrix is equal to the number of rows of the second matrix you can multiply the two matrices. Now, so suppose that we have two matrices. Matrix A is to be multiplied by matrix B. So it will be a new matrix C. Now, we have learned at the beginning of the chapter that each matrix has a unique order showing the number of rows and the number of columns. So it is, for example, matrix A is of order m by p, in which m is showing the number of rows, p is showing the number of columns. As the point is directly saying the number of columns of the first matrix. So the number of columns in the first matrix is p, should be equal to the number of rows of the second matrix. So in B, the number of rows, which is the first element, should be p, because then number of columns of the first matrix will be equal to the number of rows of the second matrix. So suppose that it is p by n. So A is m by p and B is of order p by n, and they are to be multiplied by each other. Now, as you see, if these two interior numbers are the same, you are allowed actually to multiply the two matrices. Then the product matrix will be a matrix of order m by n, as if these two common interior numbers will be omitted and the exterior ones remain. So again, in order to be allowed to multiply two matrices, the number of columns of the first matrix should be the same as the number of rows of the second matrix. So if they are equal, you are allowed to multiply the two matrices. So the product matrix will be a new matrix with a new order. What is the order of the new matrix? The product matrix is m by n. For example, if you have two matrices like 3 by 2, so this one should be 2 by, for example, something like 5. Okay, then as you see here, these two are the same. The number of columns of the first matrix is the same as the number of rows of the second matrix. So the new matrix, the product matrix, will be a new matrix of order 3 by 5. Now the question is how to find the elements of this product matrix that you will see in the next parts. Now the first example, you are supposed to find the product of the matrix 1 and 2, 3 and -1. Now, first, if you see here, you have a 1 by 2 matrix, because 1 row, 2 columns. So the order is 1 by 2. And the second one has the order of 2 by 1. because there are 2 rows and 1 column. So as these two numbers are the same, so you will have a matrix of order 1 by 1. A 1 by 1 matrix means a matrix which has just one single element, one row, one column. Now the question is how to find these elements. Now, first look at the location of these elements, the address of this element. It is located in the first row, first column. So go for the first row of the first matrix and first column of the second matrix because it is first row, first column. Now multiply corresponding elements, first element by first element, which is 1 by 3, plus second element by second element. So it will be 3 minus 2, which is 1. So it will be a 1 by 1 matrix whose element is 1. Now second example, you have again two matrices. So the order of the first matrix is 2 by 1, but the second one is 1 by 3. As you notice here, these two numbers are the same. So you will have a matrix which is 2 by 3. 2 by 3 matrix means there are 2 rows and 3 columns. 2 rows, 3 columns. So 2 rows and 3 columns. Now for each element I construct these shapes in which I'm going to calculate the elements. Now 1 by 1. So what is the first element? It is located in the first row, first column. First row, listen carefully to what I'm saying. First row, it is giving, actually it's like navigator. It shows that what elements are to be multiplied. First row, first column. So I multiply first row by first column. So 3 by 1. So there are just unique element in first row and first column. So it will be 3 by 1. Now for the second one. It is located in the first row, second column. So first row, then second column. So 3 is multiplied by 0. Now this element. First row, third column. So first row is multiplied by the third column. So 3 is multiplied by -5. Now let's go for these elements. It is located in the second row, first column. So second row is multiplied by first column. So 2 by 1. Here it is second row, second column. 2 times 0. Here is second row, third column. So 2 times -5. It will be 3, 0, -15, 2, 0, -10. 2 by 3 is the product matrix. Third example, you have again two matrices. Now as you see here, it is 2 by 2, here it is 2 by 2. Now as you see here, the number of columns of the first one is the same as the number of rows of the second matrix. So you will have a 2 by 2 matrix, these exterior numbers. 2 by 2 matrix means 2 rows and 2 columns. Now this multiplication deserves a careful attention in order to find corresponding elements which are to be multiplied. Now I go for this element. It is located in the first row, first column. So first row, then first column. Then corresponding elements are multiplied. 5 is multiplied by 3 plus 2 is multiplied by 4. First by first, second by second. Now here it is located in the first row, second column. Again, first row, but is to be multiplied by the second column. So it will be 5 by 1 plus 2 times negative 1. Now, this is located in the second row, first column. So second row is multiplied by first column. So minus 1 times 3 plus 0 multiplied by 4. And here second row, second column. So second row, second column minus 1 is multiplied by 1 plus 0 times negative 1. Now calculate 5 times 3 will be 15 and 8 23. 5 minus 2 which is 3, here it will be negative 3 plus 0 which is negative 3, it will be negative 1 and that one will be 0, so negative 1 overall, a 2 by 2 matrix. Next example, you have a 3 by 1 matrix and 1 by 2 matrix. So your matrix will be a 3 by 2 matrix. So 3 by 2 means 3 rows and 2 columns. Now, look at the location of this element. It is located in the first row, first column. So first row, in which there is just one element, is multiplied by first column. So 3 times 5. It is located in the first row, second column. So first row is multiplied by the second column. 3 times negative 2. It is second row, first column. Second row, first column. 1 by 5. Then it is second row, second column. So second row, second column. So 1 times negative 2. It is third row, first column. So third row, first column, 2 times 5. Third row, second column. So 2 times negative 2, giving you an answer of 15, 5, 10, negative 6, negative 2, negative 4 as a 3 by 2 matrix. Now, another multiplication, you have a 1 by 3 matrix and 3 by 1 matrix. So these two integer numbers are the same, the number of columns and the number of rows. So you will have a 1 by 1 matrix including just one unique element. Now, this is in the first row and first column. So first row and first column elements are correspondingly multiplied. So first by first, 1 times 2 plus second times second plus 2 times negative half. So it will be at the end 1 times 2 which is 2 minus 24, 2 times half, it will be negative 1 which will be negative 23 as a 1 by 1 matrix.